Hey everybody, how's it going? Matt here, and I'm going to try and do some live coding in Python. I'm going to make a really simple terminal-based math game for my son. So I'm going to do my best to explain what I'm doing as we kind of work through this. But without further ado, let's go ahead and dive in. So the first thing I'm going to do here is lay out a set of functions to make a frame for this program that we're going to develop. The first thing we're going to need, if I can type, is a way to start the game. Think of a start screen. The next thing we're going to need is a way to generate math problems. So we'll have a function for that. After that, we're going to need a place to actually run the game. So we'll have a game function. This is where we'll generate our math problems and also keep track of score and communicate with the player. And then finally, just like we needed a way to start the game, we also need a way to end the game. This is where we will return a final score to the player and we'll signal to them the game is over. I'm going to place these four functions all inside of what's called a main function. And really this is just a place to focus on the sequencing of our game, how we want it to start, how we want the game to be ran, and how we want it to end. So I know the first thing we're going to need to do is actually start this thing. Then after we start it, I know we're going to need to run the game. And after we run the game, under a certain set of conditions, we're going to have to end the game. And then down here, when we actually want to kick this thing off, we'll just call our main function, and our game will go ahead and start. So let's head back up to the top and go to our start function. The first thing we're going to want to do is actually greet the player. Say welcome, hit enter to continue. Now, since we're using the terminal to actually run this game, we're going to need a way to collect input or signal to the player that they need to continue. So we're going to use Python's input, which is a built-in function to retrieve information from the terminal. Input returns strings. In this case, we're not assigning the return to any variable. We're just using it to signal the player to go ahead and move forward. So we're just going to collect an input, not do anything with it, but then we're going to ask the player how many problems they want to do. And here we're actually going to assign input to a variable. So let's just make a variable called probs. Go ahead and type up our input. So I specifically want to know how many problems in a problem set we want. We can have 1 problem, 5 problems, 10 problems, 100 problems. But we need that string that's retrieved from the terminal to be converted to an integer. Okay, because we're going to use this probs variable to define how many problems we want to generate in a loop inside of our game function. So whatever is received here needs to be converted to an integer. And now I want to demonstrate something. So call it down here. This all should work. We're in the correct directory. Python 3 Math Wizard. Okay, good. Hit enter to continue. Okay, how many problems? Let's say we want to do 10 problems. So I'm going to type out. I'm going to spell 10, T-E-N. Uh-oh. We just threw an error and our program exited, terminated. So we threw a value error. What happened is when we called this input statement, retrieved TEN from the terminal and then tried to convert that to an integer, we threw a value error because you can't convert letters to numbers. So we need to add a little bit more functionality to be able to handle input situations like this and make sure we ensure a smooth playing experience for the player and also be gentle with them if they make misentries or mistype information on the keyboard. So let's define another function called get input. We're not passing any parameters, but let's start a while loop and then use a try and except statement to handle this situation. So what do we want here? Let's just say while value is equal to input. Convert that input to an integer, and then we'll say break. So basically, if this line runs successfully, if we type in 10, 1, 0, we'll convert that to an integer, we'll break out of this loop and go ahead and return the value to be used in the program. But if there's a misentry, we want to catch the error that's going to be thrown, in this case a value error, and do something else. We'll just simply say hey player, invalid entry, try again. So if an error is thrown, we'll go back to the top of the loop, and the player will get another opportunity to send entry from the terminal to the game. So let's head back up here, remove this, run get input, and then make sure down here we return probs, because we're going to need that later on in the game. Let's test this out. Let's clear this information, run, welcome, hit enter. Okay, how many problems? TEN. Invalid entry, try again. Ugh. Invalid entry, try again. Okay, 1, 0. Good deal. No error thrown, and the program exits as we intended. So let's get back into this. Let's minimize our terminal. And now what to do next? Okay, so now would be a good time to start implementing our game function. But before we can implement the game function, we actually have to implement our problems generator. So I scoped out a lot of my son's schoolwork to try and get a feel for the type of math problems he's been doing. So namely, he's been doing addition, subtraction, and multiplication. So let's make a list of operations, plus, minus, star for multiplication. And these are just all strings in a list. And I also noticed that he's doing predominantly two-term expressions. So a plus b, a minus b, a times b. A. So we need an A value and a B value, and we only need 2 of them. So how would I want to get 2 of them? Let's think about this. Well, I want these problems to be generated at random, so let's bring in the random module, which is another, this is a part of the Python standard library, and I just want a random integer. And he's pretty much working with small numbers, so we'll stick to small numbers in this case. So we'll draw a random integer, and we'll do it twice. So 4r in range all the way up to 2. So what I just did here is I used a construct called a list comprehension to generate 2 random integers twice, and then return a list with 2 random integers inside of it, and then unpack those integers into variable A and variable B. Running along the same vein, we're going to want to also select our operation at random. And random has a function for that. We're going to use random choice. We're just going to select at random one of these strings from this list. Okay. And now there's one final piece. I noticed that he's not dealing with negative numbers. So I want to ensure that all of the operations that we do are not going to produce negatives. So one way to do that is to lean on another Python built-in called sorted. So what we're going to do here is generate 2 random integers, sort them in descending order, and then unpack them into A and B such that A is always greater than B. And when we construct our math problem down here, we'll always ensure that the output is always a positive number. So I think those rules should work. And let's go ahead and display to the player what the problem is. And I'm going to use a thing called an f-string to kind of dynamically generate a sentence on the fly for the player to read. So we're just going to say, what is brackets A, close brackets, B. Okay, and this will be printed out to the player. Now we need to actually find our answer. So let's just do answer equals none for now, so we don't get any unbound errors. And then we'll use some if-else logic to use our random choices to determine the answer to the expression that we just pulled at random. So if our operation is equal to plus, we're going to do a thing. We're going to get answer A plus B. Else if now if our operation is equal to negative, our answer is going to be A minus B. Space that out correctly. And then finally, operation equal to star for multiplication. We're going to do answer equal A times B. Okay, now what do we need? So we've computed our answer. We've presented the problem to the player. Now let's give them a chance to return their input. So let's do a response variable, and let's just call get input. Okay, and maybe we should run this up here and then have the program worry about finding its own answer. So the next thing we can do is actually generate a check. We can do a Boolean comparison, a conditional comparison, to see if the player's response is equal to or the same as the correct answer. So let's just make a variable called check. It'll be response equal to answer. And this will return either a true or a false. And then we can use the check to let the player know if they answered the question correctly or not. So if check is true, we're going to do a thing. We're going to print correct. We're just going to give a bare bones input prompt to let them know to cycle forward in the game. And then if check is false, we're going to say print wrong. Very gentle here. The answer is, we're going to want to use another F string here. So let's put an F, prepend an F to this to let Python know what's going on. And then we'll just print the answer back to them. And we'll do another bare bones input to kind of break the sequencing up. There's another thing we need to do. We actually should maybe set point equal to none, because I think what we want this whole function to, we don't actually want this function to return the response or the answer. We just want to return whether the player got it right or wrong, whether they got a point of 1 or a point of 0. So we'll activate another variable called point, just set it equal to none now, and then use our logic down here to assign either a 1 if we're correct or a 0 to it if we're wrong. And then at the bottom of this function, we're going to return point. Okay, and it should work. We haven't actually called problems anywhere in here yet, so we don't necessarily need to test it right now. So this is probably a good time to go in and implement our games function. So let's hop into games. Now, problems will return whether we got it correct or not, so a 1 or a 0 for our point. But in the game, we need to keep track of all of our points. So let's define a variable called points. We'll just set it equal to 0. And now let's use the number of problems in our problem set for r and range problems. It would also be good to instantiate an argument in this function signature here for problems and problems. Points is augmented by whatever's returned from the randomly generated problem above. Okay, call that problems. So what we're doing here is we start the game. We return the number of problems we want in our problem set. We pass that to our game function, and then we use that number to generate dynamically the number of math questions we actually need for the player to evaluate. And whether we're correct or incorrect, whatever's returned from that problem generation is augmented to our total points. Now, when we finish that loop, and really looking at the loop, this is the meat of the game here. You can think of the game as the actual board that we're playing on. We have our point tracker off to the side, but the mechanic here, the problem generator, this is the actual procedure that the player is repeating over and over and over and interacting with. So after we break out of this loop and we complete our problem set, let's let the player know that they're done. All problems completed. And we are actually going to return our score, return points, because we are going to use that in our end function. So what would the end function need here? Well, I think we're going to need in our function signature the number of problems in our problem set, so just probs or problems, and we're going to need to know the number of points. So that way we can calculate the number correct out of the total problem set and then let them know how they did at the end of the day. So let's get into the body of this function. I think maybe we should compute a score, and that's just a ratio of points to problems. Okay. Now we can print another f string, and we'll just say points out of problems. Correct. Now let's use some logic to figure out how well they did on a scale. So we'll do if score is greater than or equal to 0.75. So if they see or better work here, we're going to say, hey player, need my syntax here. We're going to say, hey player, great score. Keep it up. Now, if score was less than or equal to 0.75, so just the ratio of points over problems, we're going to say print okay, score, try again. Okay, so now we have our game mechanic implemented, and this is really, again, the meat of the script, the meat of the program. We have our game environment set up. Fry and range of problems, points. Looking at that should work, even though we don't use R in the loop here, but I think we're good. We have a way to end the game. We have a robust way to actually collect our input. Now let's go ahead and tighten up our main loop here. So start's going to return a problem set, the number of problems we want to do, so we need to assign that to a variable. Game is going to return the number of points we got correct, so we need to assign that return value to a variable. And then end actually needs two variables passed to it, two arguments passed to it. First, we need problems and then points. So we'll do probs and then points. And we'll just treat these as positional arguments instead of keyword arguments. So now we have our main loop set up, ready to go. Everything is saved. The linter isn't yelling at me too much. Let's see if we can run this and move through the game. Game. What's the error there? Anyways, okay, let's clear all this out. Math Wizard, hit enter. Let's do 4 problems. Missing 1 required argument. So we're missing a positional argument in game. So if we roll up here, game, problems. Ah, yes. This is why it was yelling at me. I forgot to tell the game space how many problems it needed to generate. So let's try this again. Clear. Hit enter. Let's do 4 problems. Int object is not callable. Line number 48. Let's move back to line 48 for our in range problems. Okay, we had some variable name confusion. So now we're actually in the game. We're going to do 4 problems. Now our first problem is what's 1 times 0? 0. Correct. 8 plus 6, 14. Correct. 7 times 4, 28. Correct. 9 times 8. Uh-oh. Brain teaser. 72. Cool. All problems completed. 4 out of 4 correct. Great score. Keep it up. And really, there it is. So just kind of in summary, to revisit everything we just did, let's collapse these. Maybe space them out correctly. Okay, so we used one Python standard library module, and that was random. We defined a place to actually start our game, so we made a start screen. We asked the player how many times they wanted to play, how many problems they wanted to do. We came up with a way to generate a kindergarten level math problem on the fly. We didn't test it too much, but it's probably an 80% solution. We used that problem generator inside of our game space to actually run the game. So keep track of our points and then generate as many problems as the player wanted to do. And then we kept track of their score as we iterated through that by augmenting our points variable. Then we returned our points variable and fed it to our endgame state. So this is kind of our end screen and we let the player know how many points out of problems they got correct, and then what their final score was relative to kind of a judging metric, a scoring metric. Ran into a few issues, a few errors, maybe. You have to be careful with your namespaces, especially if you have variables and functions with the same names. We handled one error with our get input function, and that's really just making a more smooth, robust way to handle misentries and mistypes, especially coming from a kindergartner using a keyboard. And then we implemented all of this functionality above into a simple main function. By doing that, we were able to abstract all the complexities away and really just focusing on the sequence of function calls we needed to make a sensible math game. And that is really it. I hope you folks learned something. I hope you were able to follow along. If you have any questions or comments, just let me know. Thanks for listening.